Day 42 of communication practice with ChatGPT. Okay, so let's start. Good evening, ChatGPT.
Good evening. How's it going?
I wasted my whole day, I guess, because I slept too much. But anyway, I will spend my remaining energy this evening uh, on finishing my task today, starting with practicing communication with you. Today I want to practice like mock interview. I want to prepare for an interview which has also algorithm, system design, uh, pipeline coding, and maybe SQL coding. So can you help me practice with that?
Absolutely. I'd be happy to help you practice. We can tackle each section one by one. How about we start with an algorithm question, then move on to system design, pipeline coding, and SQL?
That
Let me
sounds
know which.
lovely.
Great. Let's get started. Which area do you feel like focusing on first? If you're up for an algorithm question, I can give you a problem to solve. Or if you'd prefer to jump into system design, we can do that too. Your
Uh,
call.
let's start with algorithm.
All right. Here's a classic algorithm problem to warm up. Given an array of integers, find two numbers such that they add up to a specific target. You can assume that each input would have exactly one solution, and you may not use the same element twice. Take a moment to think about how you'd approach this, and then walk me through your solution step by step.
Okay, so the array is integer. So the naive approach that I would think of is brute force, using two loops. The first loops uh, look for the first number, and the second loop start from the next number to the end of the array. And if the sum of that two number equal um, equal the target, then we will return those two number. But this has O square of n time complexity and O1 space complexity. Um, so would it would not be efficient for large n. So I'm thinking about a second approach which we can leverage the set in Python. For that, we will initialize a set for the counterpart uh, and uh, and do the loop for each first number. We will save the target minus that number into the set, so that when the next time the number appear in the set, we know that that is the second number that we are looking for, and then we can return those value.
That's a solid explanation. Your second approach is definitely more efficient. By using a set or a hash map, you reduce the time complexity to ON and only use ON extra space. It's a common and effective solution for this problem. Ready to move on to another topic, or do you want to try another algorithm question?
Yeah, I'm ready for a medium algorithm question.
All right. Here's a medium level algorithm question. Given a string, find the length of the longest substring without repeating characters. Take your time to think it through and then explain how you'd solve it.
Okay, so again, the naive approach would be we use two loop. The first loop we start uh, from the first character, and the second loop will start from the next character, and then for each loop we will compare the length of the substring that contain no repeatable characters. and we save it to a rest variable and return it um, after to loop is done. But essentially, this approach has on square n time complexity and on space complexity. We can also approach this in a more efficient way by using two pointer and hash map. So we gonna initialize the left and right variables for the iteration, and we essentially we will move the right pointer to the most right with the constraint of the condition, and we save the character into the hash map. And if the new character that the right pointer is pointing to is in the hash map, which means it is repeatable, and we will compare the result variable, and then we move the left pointer until it it meet the condition, and move the right again, and get and by that we get the result that we want and return it. So this approach has on on actually it O2n equal on time complexity, because we use two pointer to loop through the array, and the the space complexity is also on for the hash map to store the characters. So
Excellent breakdown. Your optimized approach with the two-pointer technique and a hash map is spot on. This sliding window method ensures you only traverse the string once, making it on time complexity, and the on space complexity is due to the hash map storage. Great job breaking down both the naive and optimized solutions. Is there anything else you'd like to practice or discuss?
now let's move on to the system design questions.
Great! Let's dive into a system design scenario. Design a URL shortening service like Bitly. The service should take a long URL and return a shortened version. It should handle a large number of requests and ensure that each shortened URL is unique. Also, consider how you would handle database scaling, caching, and ensuring the service is highly available. Take your time to outline your approach and the key components you'd use.
Okay, this is not my area of comfort comfortables, but still, if I have um, to design that system, I would thinking about some aspect. So first, about the back end of the about the application of the system, people. So it would I would do some for the people to reach the server and request the about the API. I'm thinking about two main barebone API here. So first is for the um, create new short link, and the second is for get the short link. So for the create a short link, given a URL, we have to return a shortened version of it. So we can use catch here. So if the if the URL here is also done by other, it will be catch, and if it hits, it return. If it miss, we're gonna have to look Um, for this is a create a request. Um, if it miss, we have to create it eventually. So we might want to do um, some hash function to reduce the URL uh, and save it into a database, and also save it to the cache. And for the next time it is queried by the get request API, it will search from the cache first before reaching to the database. And so that is what I'm thinking of, and about the scalability of the database and the cache. The database should have um, it can be the relational database, and um, we can somehow use the leverage the distributed database here, so that it can be scaled horizontally, uh, and I'm not I am not familiar with any names, so please give me some feedback and answer of the question.
You're on the right track. Let me give you some feedback and fill in a few details. First, API endpoints. You correctly identified the two main APIs, one for creating a shortened URL and one for retrieving it. Hashing and unique IDs. Using a hash function to generate a unique ID for each URL is a common approach. To ensure uniqueness, you could append a counter or use a base 62 encoding. Database. For the database, a NoSQL database like Cassandra or a key value store like Redis is often used to handle a high volume of reads and writes. For relational databases, sharding and replication can help with scaling. Caching. Implementing a cache like Redis or Memcached for frequently accessed URLs will significantly reduce database load and improve performance. High availability. To ensure high availability, you can deploy multiple instances of the service behind a load balancer and use replication for your databases. 6. URL expiry and analytics. You might also consider adding features like URL expiry and tracking analytics for shortened links. Overall, you covered the core aspects well. The main goal is to ensure efficiency, scalability, and reliability of the service. Let me know if you'd like to dive deeper into any part.
Wow, that's a very comprehensive answer. I, I didn't know that much, to be honest, because as a data engineer, I don't quite, focus on that. But anyway, thanks for pointing that out. I'm ready for the next area.
You're welcome. It's great that you're exploring different areas. Let's move on to pipeline coding next.
Mm.
Imagine you need to design a data pipeline that ingests log files from multiple servers, processes them to extract specific metrics, and then loads the data into a data warehouse. How would you design this pipeline, and what tools or technologies would you use to ensure it's efficient and scalable? Take your time to outline your approach.
May I ask what is the file format of the log file?
Of course, let's assume the log files are in a common format like JSON, where each log entry is a JSON object containing fields like timestamp, log level, message, server ID, and other relevant metadata. This format makes it easier to parse and extract specific metrics during processing.
Okay, and what is the target file that we are looking for?
Let's say the target data warehouse is a columnar database like Amazon Redshift. The processed metrics from the log files will be transformed into a structured format and loaded into tables optimized for analytical queries. This will allow efficient querying and analysis of the extracted metrics.
Okay, so for that, I believe we can um, we can leverage. I believe in AWS Redshift, we already have some kind of connector to the source, like files, JSON files, and uh, give the query based on that before saving to the data warehouse. But by using Spark, we can read from JSON file format, doing something like spark dot read dot format JSON, and dot the location of those files, and saving and manipulating with the data frame before saving, and transform and add with new column as many as we want before saving to the data warehouse, file object storage, or Redshift API. I'm sorry, Redshift AWS.
Exactly. Using Spark to read and process the JSON logs allows you to perform transformations and aggregations efficiently. After processing the data into the desired format, you can use the Spark Redshift connector to load the transformed data directly into Amazon Redshift tables. This approach ensures that the pipeline is scalable, as Spark can handle large volumes of data, and Redshift is optimized for analytical queries. Great job outlining the process. Let me know if there's anything else you'd like to cover.
Yeah, I'm ready for the next area.
Awesome. Let's move on to the SQL coding part. Suppose you have a table called user activity with columns user ID, activity type, timestamp, and session ID. Write an SQL query to find the number of unique users who performed the login activity each day over the past 30 days. Take a moment to think it through and explain your query.
Uh, can you repeat the problem, the problem part of the question? What do I need to find?
Sure. The task is to find the number of unique users who performed the login activity each day over the past 30 days. In other words, you want to count how many distinct users logged in on each day in the last 30 days.
Log in each day. So okay. I need to be more clarify on this. Um, so we require the user is have to log in every day in the last 30 day, right?
Ah, good question. No, you don't need the users to have logged in every single day. Instead, you're looking for a daily count of unique users who logged in on each day over the past 30 days. So for each of the last 30 days, you just count how many distinct users performed a login activity on that day.
Okay, well that should be trivial. Um, so we because we have to count number of unique user that log in by day. So essentially, my answer would be select to date timestamp as date, uh, then count distinct user ID from the user table where the category or the action column is login, and the timestamp uh, greater or equal than current than current date minus 30 days, interval 30 days, group by one, which is group by two date, uh, timestamp. So that is my answer.
Perfect. Your query is spot on. It selects the date from the timestamp, counts the distinct user ID who logged in on each day, and groups the results by date, filtering for the last 30 days. Great job breaking it down and writing a clear query. Is there anything else you'd like to go over or practice?
No, I think that's all for today. Thanks for having me, for helping me.
You're very welcome, anytime. Good luck with your preparation, and feel free to reach out if you need any more help. Have a great one.
Have a great one.